In our last video, we took a look at chemical compounds, chemical formulas, a little bit about chemical equations, and I talked about the law of conservation of mass. Today in our video, we want to go further into looking at chemical equations and the parts of those equations. First, we have to remember that there is a law called the law of conservation of mass. And the law of conservation of mass, in a chemical reaction, no elements or atoms are created and no elements are destroyed. Only bonds are broken and new bonds are formed. What this means is that when we're looking at chemical equations, the equation must be balanced. In other words, we will have the same kind and number of elements on both sides of the chemical equation. And as we go through the video, we'll see more about this. So let's look at this chemical equation to figure out what the different parts are. First, let me read the equation to you. If I were to read this equation, it says that 2Ag plus H2S produces Ag2S plus H2. Basically what this means is that we have two reactants, silver and hydrogen sulfide, and when they are put together they react to create silver sulfide plus hydrogen. Now, breaking down this equation, on the left side of the equation, this is called the reactants. On the right side of the equation, we have the product. In other words, we have two silver atoms and one hydrogen sulfide molecule that are reacting together, and they are creating, when they react chemically, and they are creating a silver sulfide molecule and one molecule of H2 or hydrogen, two hydrogen atoms together. Alright, going further now, let's look at first this 2 here. The 2 right here is called a coefficient. Right. The plus sign breaks down this, telling us where one molecule stops and another molecule begins. So this is just a break showing us the different reactants. It breaks the reactants apart. Then we go over here to the H2S, the little 2, we'll talk more about this in a minute, is called a subscript. And basically what a subscript is, it just tells you that in a molecule that you have this many atoms of that particular element. If it's just one atom of an element, we don't put a subscript. We, like the S here, there's one atom of sulfur, but we don't have to put the 1. If it's more than 1, we'll put a number. Now, between the reactants and the product, you see this arrow. This arrow, when we're reading the chemical reaction, we read the arrow as produces or yields. So let's talk a little bit more about coefficients and subscripts. Let's start with a coefficient. A coefficient is a number that is found in front of an element, a compound, or a molecule in an atom. So in the last chemical equation we looked at, we had, I believe, Ag2S. So that's a compound or a molecule of silver sulfide. The 2 in front of it simply tells us that there are 2 of these molecules or compounds in the formula. So let me draw that out for you. Basically, all it says is that there are 2 silver sulfides. So if I were to draw it out, we would have a silver atom, and this 2 here shows us that there are actually 2 silver atoms and 1 sulfide atom in this molecule. The coefficient tells us that there are 2 of these molecules. So let me draw one more. And that's what this 2 just says, that there are 2 of these molecules in the chemical equation. When we start looking at breaking down chemical equations in a minute, or to see if they're balanced or not, and when we start to balance chemical equations, the coefficient is the only thing in a chemical equation that we can change, because it does not change any element or compound or molecule. Therefore, we can change coefficients. We have to have coefficients in front of an entire compound or molecule, though. We can't put them in between. So they always go in front of the molecule. In other words, if we had another reactant here, we could have a coefficient over here as well, and I'm just making this up, but we could have plus 3 H2Os, and we couldn't put the 3 in the middle of this molecule, or we couldn't put them in the middle of these molecules. It couldn't go there or there. It has to go in front of the entire molecule. Now let's take a look at a subscript. We'll use H2O for this because we're all familiar with water. This subscript simply tells us that there are 2 hydrogen atoms in the molecule. So we've got 2 hydrogen atoms and 1 oxygen atoms, and that's a molecule of water. Didn't draw that very well, but that's kind of the idea there. Now, this 3, remember, and the coefficient, this 3 tells us that there are 3 of those molecules. Kind of looks like a frog, doesn't it? But there's 3 of these molecules. That's where the coefficient comes in. But remember that the subscript simply tells us that there's 2 hydrogen atoms in each of those molecules. So if we wanted to find out how many hydrogen atoms were involved in this part of the reaction, we would simply multiply 3 times 2, and that would give us 6 hydrogen atoms. 1, 2, 3, 4, 5, and 6. So there's a big difference. Remember, the coefficient is something that we can change if we are balancing equations, but the subscript we can never change. We can never take away or add subscripts. They have to remain that. Because if we were to For example, to change this subscript to a 3, H3O, we've now changed that molecule to something besides water. H2O is water, not H3O. So we can't take away or add any subscripts. So let's look and see how we can determine if a chemical formula or chemical equation actually is balanced or not balanced. This chemical formula looks pretty daunting. It's really not that difficult. The best way to do this is to take a T-chart and break it down into two sides. Now all we're doing is counting the kind and number of each of the elements on each side of the equation. So since this starts with hydrogen, let's take hydrogen and we'll just count how many hydrogen atoms are in the reactant side. And notice we have 1, then we have 3 more, so that's 4. Here's another one, and that's 5. So there are 5 hydrogen atoms in the reactant. Now let's go over here to the product and count hydrogen atoms. We go across, there's 3, there's 2 more, that's 5. So there's 5 hydrogen atoms in the product. Alright, let's go back over to the reactant side and count carbon atoms. There's 2 carbon atoms there. And here's 1 more carbon atom, so there's 3 carbon atoms in the reactant. Let's go back over to the product side and count carbon atoms. Here's a carbon atom. There's 2 carbon atoms there and 1 carbon atom there. So that would be a total of 3 carbon atoms. And we'll go over, we've done hydrogen, so now we'll do oxygen. There's 2 oxygen atoms here. There's 3 oxygen atoms here for a total of 5 oxygen atoms. Go over to the product side, we'll do the same thing. Go across, there's 2 oxygen atoms. There's 1 oxygen atom. That's 3, and there's 2 more, and that's a total of 5 oxygen atoms. And then we just have 1 more element actually, and that's sodium. There's 1 sodium atom on the reactant side. So sodium is 1. We go over to the product side. There's 1 sodium atom there. And so if we look, we have the same elements in the same numbers on each side of the equation, and that makes the equation a balanced equation. Alright, so here's a chemical equation that I'm guessing is not balanced. Let's do the same thing as we just did. Let's make a T-chart. We'll break down the elements. We're looking at first at iron, at Fe. There's 2 Fe's on the reactant side. There's 2 of them. Let's look over here on the product side. Over here there are 3. There are 3 iron atoms over here. Alright, so that doesn't balance. We've got on the on the reactant side, we have 4 oxygens. 4 of them. And on the product side, we have 6 oxygens. So that doesn't balance. And then on the reactant side, we have 1 carbon. And on the product side, we have 1 carbon. So those 2 actually balance. So we have 1 carbon and we have 1 carbon. So now what we have to do is add coefficients in order to balance this equation. We have 2 irons over here, and we have 2 irons on the product side. We have 2 irons on the reactant side, we have 3 on the product side. So we have to get the same number of oxygens, we have to get the same number of iron atoms on each side of the equation. Well, the best way to do that is to come up with a number that we can multiply by each 2, the smallest number we can. So both of these 2 and a 3 will both go into 6. So I'm going to change a couple of things here. I'm going to put a 3 in front of this iron, and I'm going to put a 2 in front of this iron. So now we have over here, we have 6 irons, and now we have 6 irons over here. Let's see what that did to the rest of the equation, though. Now let's take a look at oxygens. This coefficient will go with this oxygen here too, so we got to multiply. 3 times 3 is 9, and then we have one more over here, so now we have 10 oxygens. So we're going to mark that out, and we're going to go 10 oxygens. Let's look and see what it did over here. We have now 2 times 4. I'm sorry, we have now 2 times 4 is 8 oxygens, and another 2 would be 10 oxygens. So now we have a total of 10 oxygens, and we continue to have 1 carbon, 1 carbon. So now our equation is balanced. Let me write it out again here for you where you can see it a little better. We have 3Fe2O3 plus CO produces 2Fe3O4. I'm sorry, that's O2, I believe. Let me check that real quick. I'm sorry, that was a 4 there. So we have O4. I might want to erase that so it'll show up better. O4 plus CO2. And we have a balanced equation. In the 8th grade, we're not so worried about balancing equations, but if you know how to do it, you'll be far ahead of the game next year. But we do have to be able to count the elements and tell if the equation is a balanced equation or not. And so that ends our lesson today on looking at the parts of a chemical equation and looking to see if our equations are balanced or not. Remember, the law of conservation of mass says that in a chemical reaction, there are no elements that are created and there are no elements that are destroyed. Only bonds are broken and new bonds are formed.